The genesis behind this project started with a flat tire. A big one. A flat tire on this thing. That's our M923. By the way, come check us out in Virginia City, Montana. NelsonStudios, Alder Gulch Summit Tours. We'll give you a ride. Mention YouTube. I'll give you a discount. We're pretty cool. Anyways, the tires on the truck are what we call a combat rim, which is a two-piece rim designed to be changed in the field, and that part works perfectly. The downside is that mine have gotten a little rust in there, and because they're a little rusty, they don't seal quite right anymore. And it's been a difficult time finding O-rings large enough to bridge the gaps. Oh, I can find the proper O-rings. They're just not large enough to deal with the rust and the other issues down inside. And I was looking at some silicone rings and chasing the idea of having some silicone O-rings custom made for the truck when I stumbled across an Instructable. It was an Instructable posted by Captain Chriso, and it detailed how he made custom smaller O-rings using tubing for his underwater projects. Now I wondered if I could apply his idea to something this large. And that's where the whole thing got its start. It begins with a board, a mold. In this case, I need a ring that's about 19.5 inches in diameter so that I can stretch it over my 20-inch rim. I wanted something that was a little thicker than what I could purchase commercially, which seemed to be about 1/4 of an inch. But I also wanted it a little wider. What I was hoping for was something about 19.5 inches in diameter, about 3/8 of an inch thick, and about 1/2 an inch wide. A band, a belt, if you would, that I could then put around my rim. Here I am making the mold, and I'm using a laminate router and my own custom little swing arm there to route out a round hole, taking a little bit at a time, getting down to the depth that I wanted. I was concerned that the MDF that I used as a mold would be rather porous and that the silicone would impregnate itself into those pores, and then as a result it would stick. It would stick really hard and I wouldn't be able to get it out. Now, Captain Chriso had recommended coating the whole thing with wax, but I just wasn't sure how far the wax was going to go. So what I did is I took some Elmer's carpenter glue and I basically painted the entire channel so that the wood glue would soak into the fibers, locking them together, and then later I sand it, and the net result is a much smoother and, more importantly, harder surface that the silicone can't impregnate. After giving the piece ample time to dry, I went in with some coarse folded sandpaper and scrubbed out the sides and bottom of the mold. It provided a hard, durable surface that the silicone, I hoped, wouldn't stick to. One bit of advice Captain Chriso did impart to me was to be sure to wax the mold, and that's what I'm doing here. I've just got a melted candle. It smells a little bit Christmassy, if I'm honest, and I'm painting the bottom and sides of my mold with this wax in order to create a non-stick surface. I'm trying to bridge the gap between using the wax to level and flatten and smooth out the mold and having so much wax in there my gasket ends up being smaller than my original design. I don't know. I found a happy medium somewhere in between. Waxing it's important. Beyond that, I wouldn't worry about it. Here I am just taking a razor knife blade, using it like a scraper to clean off the extra wax along the top edge, also cleaning it out of the bottom groove. I also took the time to wax up a pair of test strips I made, and I would encourage you to do this as well. It's how you know when the silicone is cured. I made sure to practice on my 2 test strips first, which is good because there were some bubbles right at the end of the silicone, which, as you'll see later, kind of contaminated the test strips. And then I used a razor knife to clean them off. The silicone isn't necessarily special. Here's the deal. It has to be 100% silicone and not silicone 2. Now, it used to be that Silicone 1 and Silicone 2 were individually labeled. It doesn't appear to be today. What I got is a tube of 100% silicone that just did not say it was Silicone 2. I tried to carefully ease it in there, starting from the bottom and creating a wave that sort of pushed the silicone back up and behind itself till it bowed out on the top. I ended up using quite a bit more silicone than I needed in this process. It's kind of hard to describe. You'll have to do it and then overdo it once in order for you to figure it out. And then when I came together, I just tried to not get any bubbles. Here I'm using that same razor knife to straighten off the top, scraping up all that extra silicone that I put in there so that I would have a good, stout, level top edge. It worked pretty good. Here we are, better than a week and a half, maybe even 2 weeks later, and I'm ready to see the results. I'm using a curved dental pick there, and I go in alongside, holding pressure against the edge of my mold, down both edges, and then I use the pick to sort of work underneath the spot and begin the process of pulling it up. It removed rather easily. I was worried about there being more problems. Now it turned out there were some bubbles that I had gotten into the mix on that piece of silicone. But all in all, it was surprisingly tough.
On the surface, it's really pliable. However, see that? That's where a bubble was, and another bubble. They're still really strong, mind you. But those bubbles, those don't make me a happy boy.
I guess there's nothing for it. How did we do with the big one? Going in, down along the side. Going in, down along the inside. Going along the inside edge, I hold pressure against the mold wall. I don't want to introduce any cracking or cuts. Oh my. It worked perfectly.
I mean, I guess I shouldn't be surprised, but wow.
I've got some wax stuck to it that I'm going to have to clean off. This was a piece of my test strip that had fewer bubbles. I must have done a much better job on this one than I did with my test strips. My suspicion, I was poking and prodding at my test strips. This is how I found out when the ring was ready. Although if I'd have just left it for a week and a half like I did, it would obviously be ready. But this is a pretty flawless piece here. I'll say that this is much worse condition than this ring overall. So let's I mean, I'm able to break it, but it's not easy. So it's not totally weak like I feared it might be. the top of the ring is a much rubberier, sort of chewy feel than the bottom of the ring. And I wonder if even after all this time, the bottom could still use a little curing. Which is fine, because the application that I made this for, which is a two-piece combat wheel for an M923 Army truck, that I can't seem to, it's not that I can't find rubber gaskets, it's just I can't find the gaskets I want. The rims are all pitted up, and I just want an extra thick one. And they want me to machine the wheel, and I guess I could use like JB Weld. But anyways, I just wanted a thicker ring. I just wanted what I wanted. That makes sense? I'm tickled to death. I gave it about a 70% chance of coming out of the mold intact. But if I was honest, only about a 10 or 20% chance of being strong enough to use in the Army truck. But no way, man, that just rose dramatically. So there it is. Making up your own silicone gaskets. Ain't she a beaut? Even now, I'm still just tickled to death at how well that worked. I mean, there are few things that surprise me anymore, but that one did. Help promote some of our other videos if you're at all interested. In the upper right corner is changing out the axle boot on that M923, and the bottom is looking at lathe tools in high speed.